You know, in the IT world, we spend a ton of time worrying about what happens when a single server goes down. But what about when the problem is way, way bigger? We're going to dive into a really powerful solution in Windows Server 2025 that's designed to keep your business running no matter what happens. No, really, just stop and think about that for a second. What happens if the whole building goes offline? We're not talking about a simple hardware failure. We're talking about a fire, a flood, a massive power grid failure, something that takes your entire site out. What's the plan then? All right, so here's how we're going to break this down. First, we'll look at what a real site failure means. Then we'll introduce the solution, the stretched cluster. We'll get into the nitty-gritty of how it all works, talk about that amazing zero downtime promise, and finally, we'll cover the one big catch that makes it all possible. Okay, first things first, let's be super clear about what we're up against. This isn't about a single bad hard drive or a power supply failing in one of your racks. Oh, no, this is a whole different ballgame. We're talking about the kind of event that takes out your entire data center. Yeah, backups are great, they're essential, but restoring everything takes time, and that's time your most important applications just don't have. You need something that kicks in automatically and instantly. And that, my friends, brings us to the hero of today's story, the stretched cluster in Windows Server 2025. This isn't just some patch or a quick fix. This is a fundamental architectural design built from the ground up to handle this exact kind of site-level disaster. So here's the core idea. Imagine your server cluster, but instead of it living in just one building, it's stretched across two completely separate physical locations. Now, to all your apps and services, it just looks like one big happy cluster. But behind the scenes, you've got a whole backup site ready to take over in a heartbeat. And what's really awesome here is just how much this can protect. We're talking about the absolute heart of your operations. Your Hyper-V virtual machines, your critical SQL databases, your main file servers. And it's super flexible too, working with modern setups like Storage Spaces Direct and your more traditional SAN storage. Okay, so we get the what, but how does it actually do it? How does it pull this off? Let's peel back the layers because the way this thing is engineered is seriously clever. You've basically got two main ways to set this up. First, there's active-active. In this model, both of your data centers are online and running workloads at the same time. It's fantastic for balancing the load. Then you've got the active-passive model. Here, one site is your primary workhorse, and the other is basically a hot standby, just sitting there waiting for the moment it's called into action. And right here, this brings us to a huge, huge potential problem. What happens if the network connection between your two sites gets cut? How does Site A know if Site B is actually down, or if it just can't talk to it anymore? What's to stop them both from trying to be the boss? Yeah, this is what's known as a split brain scenario. And let me tell you, it is the absolute nightmare for anyone managing a cluster. If both sites think they're in charge and start writing data independently, you get chaos. You get data corruption. It totally defeats the purpose of the whole system. So how do you solve it? Well, the answer is actually really elegant. You bring in a third party, a tiebreaker. This is called the witness. And the key is it has to be in a completely separate third location. The witness has one simple job: be the single source of truth. If the two main sites lose contact with each other, they both race to check in with the witness. Whichever site can talk to the witness wins. It gets to be the authoritative one, and the other one has to stand down. It's a brilliant and simple way to prevent that split-brain disaster. And this witness can be something as simple as a file share, or even better, a cloud witness up in Azure for maximum resilience. So this whole architecture, the two sites, the synchronous data, the witness, it's all working together in service of one incredible goal. What you get is true, honest-to-goodness, site-level disaster recovery. If one of your data centers literally falls off the map, the failover to the second site is automatic and almost instantaneous. Your most critical apps just keep on running. Your users, they probably won't even notice anything happened. And Windows Server 2025 has made the networking side of this even smarter and smoother than before. And this is the ultimate promise: zero, or as close to zero as humanly possible. When a catastrophe hits one site, the other just takes over, seamlessly. It's the very definition of continuous availability. Now, this all probably sounds like some kind of IT magic, but it isn't. It relies on one very real, very physical requirement. There's a catch, and it's a really important one to understand. The secret sauce that makes that instant failover possible is something called synchronous replication. What this means is that every single time a piece of data is written in Site A, it has to be written at the exact same moment in Site B. Only then does the system confirm the write is complete. The data in both locations is always in perfect, identical lockstep. And to make that happen, you need an absolutely phenomenal network connection between your two sites. We're talking massive bandwidth to handle all that data traffic, and, this is the crucial part, very, very low latency. The time it takes for a signal to go there and back has to be incredibly short. The actual speed of light becomes a factor, which is why you often hear these called campus clusters. They're connecting sites that are fairly close to each other. So I'll just leave you with this final thought to chew on. When you have a system where failover is automatic, it's instant, and it protects you from losing an entire site, it really makes you wonder, right? Are we moving beyond just recovering from a disaster and into an era where our most critical systems can have something more like disaster immunity? It's a pretty powerful idea.